Hello again, and welcome back to Epidemics and the History of Medicine. Today we are going to begin studying polio, and this is subtitled The Power of Public Perception and the Birth of National Medical Research Funding. With the plague and cholera, we have learned about two serious illnesses caused by bacteria that resulted in pandemic illness. Today we are going to begin studying polio, a disease caused by a virus. Viruses are microorganisms that are smaller than bacteria and that cause many diseases in humans, animals, and plants. They consist of a protein coat surrounding an RNA or DNA core of genetic material, but have no semi-permeable membrane. They are capable of growth and multiplication only in living cells, invading and using the host cell's own chemical machinery to survive and replicate. Viruses may reproduce with fidelity or with mutations, and the ability to mutate is responsible for the way that some viruses change slightly in each infected person. This makes treatment difficult. Viruses cause many common human infections, ranging from the common cold to AIDS. Viruses may contain either DNA or RNA as their own genetic material. RNA viruses use an enzyme called reverse transcriptase that permits the usual sequence of DNA to RNA to be reversed so that the virus can make a DNA version of itself. Viruses are grouped into several major families based on their shape, behavior, and other characteristics. These include the herpes viruses, adenoviruses, papoviruses like the papillomavirus, pox viruses, and parvoviruses among the DNA viruses. Major RNA virus families include the picornaviruses, caliciviruses, paramyxoviruses, rhabdoviruses, filoviruses, and retroviruses. Many viruses are host-specific, capable of infecting and causing disease in humans or specific animals only. Polio is a picornavirus, and this diagram just shows the simple virus structure with a core of genetic material surrounded by a membrane. And this is the depiction of the virus life cycle, where the virus enters a cell, takes over the genetic machinery, and then exits as many viruses which go on to infect other cells. Finally, the next slide is a picture of the poliovirus by electron microscopy. Polio is a member of the enterovirus subgroup family Picornaviridae. These are small, ether-insensitive viruses with an RNA genome. There are 3 poliovirus subtypes with minimal immunity between them. The poliovirus enters through the mouth and multiplies in the throat and the GI tract before the onset of illness. The virus invades local lymphoid tissue, enters the bloodstream, and then may infect cells of the central nervous system. Replication of poliovirus in the spinal column and the brainstem results in cell destruction and causes the classical manifestations of the dreaded paralytic poliomyelitis. The incubation period for polio ranges from 3 to 35 days. The response is highly variable and has been categorized on the basis of the severity of the clinical presentation. Up to 95% of all polio infections are inapparent or asymptomatic. The ratio of inapparent to paralytic illness is at least 200 to 1. Infected persons without symptoms still shed the virus in their stools and are therefore able to transmit the virus to others. 4 to 8% of polio infections consist of a minor non-specific illness with no evidence of central nervous system involvement. This clinical presentation is known as abortive polio and is characterized by complete recovery in less than a week. Non-paralytic aseptic meningitis with symptoms of stiffness of the neck and back occurs in 1 to 2% of polio cases. Increased or abnormal sensations can also occur. Typically, these symptoms will last from 2 to 10 days, followed by complete recovery. Fewer than 1% of all polio infections result in paralysis. The paralytic symptoms usually begin 1 to 10 days after the prodrome and progress for 2 to 3 days. Generally, no further paralysis occurs after the temperature returns to normal. Additional prodromal signs and symptoms can include changes in the reflexes and severe muscle aches and spasms in the limbs or the back. The illness progresses to flaccid paralysis with decreased deep tendon reflexes and reaches a plateau without change for days to weeks. Strength then may begin to return. Patients do not experience any sensory loss or any change in their ability to think. Many persons with paralytic polio recover completely, and in most, muscle function returns to some degree. Weakness or paralysis still present 12 months after the onset is usually permanent. Paralytic polio is classified into 3 types depending on the level of involvement. Spinal polio is most common, accounting for approximately 80% of cases, and it's characterized by asymmetric paralysis involving the legs. Bulbar polio leads to weakness of muscles innervated by the cranial nerves, and this is the most serious form because it can involve breathing. And there can be a combination of bulbar and spinal paralysis in about 18% of cases. The death rate for paralytic polio is generally 2 to 5% among children and up to 15 to 20% for adults. This increases to 25% to 75% when there is bulbar involvement. Humans are the only known reservoir of poliovirus, which is transmitted most frequently by people with inapparent infections. There is no asymptomatic carrier state except in immune-deficient persons. Person-to-person spread of poliovirus via the fecal-oral route is the most important route of transmission. Infection typically peaks in the summer months in temperate climates with no seasonal pattern in the tropics. Poliovirus is highly infectious with seroconversion rates among susceptible household contacts of children of nearly 100% and greater than 90% among susceptible adults. Persons infected with poliovirus are most infectious from 7 to 10 days before and after the onset of symptoms, but the virus may be present in the stool for up to 3 to 6 weeks. The polio epidemics differ from the others we have already studied because they occurred during the 20th century and therefore are well documented in the medical literature and in the lay press. Public involvement in the fight against polio was a very significant part of its history. Early records identify polio in individual cases as early as 1500 BC, as shown on this slide. And there are sporadic references to paralyzed children throughout the Middle Ages and the Renaissance. By the mid-1800s, small outbreaks of polio, then called infantile paralysis, were reported in Europe, characterized by young age of victims and seasonal occurrence in the summer. The first recorded polio epidemic in the United States occurred in the summer of 1894 in Vermont. A young doctor named Christopher KAVEY took care of all of the victims and recorded the experience carefully. There were 123 recorded cases, 84 under 6 years of age. The illness began with headache, fever, nausea, and a stiff neck, and progressed to permanent paralysis in 50 cases, and death in 18. Remember that the vast majority of cases would be asymptomatic, so the actual incidence of paralysis and death would be much lower. A summary of his work was published after his death, and a mock-up of the cover of this report is shown on the next slide. This was one of many similar outbreaks in Western Europe and North America reported at around this time, characterized by the same insidious onset in young children in the summer months and with the same serious residua of localized paralysis in approximately half of survivors. In paralytic polio in the acute stage, the muscles of respiration can be affected, with paralysis leading to respiratory failure. There was no treatment for this until 1927, when 2 researchers at Harvard University devised a tank negative pressure respirator called an iron lung that could maintain respiration artificially until a person could breathe independently again. A pump passively changed the pressure inside a rectangular airtight metal box, pulling air in and out of the lungs. Inside the tank respirator, the patient lay on a bed that could slide in and out of the cylinder as needed. The side of the tank had portholes so attendants could reach in to provide care. The iron lung is virtually pathognomonic of polio, and a toddler is shown in an iron lung on this slide. Children who survived paralytic polio were often left with flaccid paralysis involving the arms or legs and needed braces and crutches to allow them to walk. And you can see the little girl on the right in this picture has long leg braces and crutches. Although the causative agent for polio had been isolated by Karl Landsteiner in 1908 as a tiny filterable agent, invisible even with the strongest microscope, little progress had been made in identifying its pathophysiology and none in finding a treatment. At this time, polio was appearing more widely in the United States, with 2,000 cases in New York City in 1907, followed by similar epidemics in Massachusetts, Minnesota, Ohio, Wisconsin, and Vermont from 1910 to 1914. Then, in the summer of 1916, there was a major polio epidemic in New York State. Beginning in June in Brooklyn, the disease ultimately spread throughout the state, involving over 30,000 patients with 6,000 deaths, 80% in children under 5, before it ended. On August 20th, 1916, the New York Times covered the epidemic on the front page, and a clipping from this is shown on the next slide. The Smithsonian described the response to the epidemic graphically. But this knowledge availed doctors little in the scourge summer of 1916. Local newspapers reported that by the 1st of July, 350 New York children had been paralyzed by the disease and 75 of them had died. On the afternoon of July 3rd, the City Health Commissioner issued a series of orders. Of the 51 biggest celebrations planned for the 4th of July, 15 would be canceled. Plans for city-sponsored open-air movies would also be scrapped. Children under 16 years of age would be banned from all places where large crowds gathered. More than 500,000 leaflets would immediately be printed and distributed, explaining what was known about the disease and urging the populace to take precautions. The new rules went properly into effect, and the polio bug slapped them aside. 113 new cases were counted on July 5th, and 133 followed on the 6th. Terrorized New Yorkers began freelancing solutions. Cats, many people concluded, were responsible for spreading the bug. When word got out that there was a bounty on the animals' heads, boys in Brooklyn rounded them up and brought them hissing and scratching to be euthanized. When the bounty turned out to be a rumor, the boys killed the cats themselves. More than 70,000 cats were killed that month, but the epidemic roared on. If cats weren't responsible, perhaps mosquitoes were. If it wasn't mosquitoes, it was rats, or sewers, or the always dirty Gowanus Canal that runs through the heart of Brooklyn. New Yorkers called, cabled, and wrote the Department of Health with all manner of things they were certain were causing the plague, including high groundwater, ice cream cones, excavations, flies, bedbugs, street dust, cornflakes, the subway, parasites in the water, alloys in cooking utensils, gases from munitions factories, the bent-over position children assumed at school desks, mercury poisoning, white clothing, earthquakes, volcanoes, electrical disturbances, sunburn, intestinal derangement, secondhand bedding, decayed food, excessive glare, unclean milk bottles, carrying coins in the mouth, and tobacco. Tens of thousands of people decided to quit the city altogether. For people without the means to flee, there was little to do but wait. In October, the weather at last grew cool, and New York City could begin to put the season of terror behind it. In the end, doctors counted 27,000 cases of poliomyelitis around the country, 6,000 of them fatal. 9,000 of the victims lived in the boroughs that made up New York City. And this is from an article called Conquering Polio, written by Jeffrey Kluger in the Smithsonian Magazine of April 2005. Although it was reported to the public as beginning in immigrant Italians from the slums of New York City, public health experts studying the epidemic found that polio actually occurred in areas with the lowest population density and the best living conditions. By contrast with most other epidemics, which arise in the worst living conditions, doctors and scientists were baffled by this disease, which seemed to strike the young in the healthiest environments. The evolving history of medicine intersects critically with the increasing incidence of polio cases in the early 20th century. Widespread acceptance of the germ theory as the cause of disease at the end of the 1800s led to a national passion for cleanliness and sanitation that persists to this day. There were public health measures like rules requiring vaccination and laws governing food safety. There was a dramatic rise in indoor plumbing and sanitary public water fountains. Magazines and newspapers covered the danger of germs, and industry responded with products designed to appeal to an increasingly germ-averse population. Posters exhorted mothers to keep their homes sanitary to protect their children from polio. One of these posters is shown on the next slide. In response to improved sanitation coupled with medical advances, many epidemic diseases like diphtheria, cholera, and typhus were on the decline. One important but unintended consequence of this national obsession with cleanliness was decreased exposure to infectious viruses early in life, when maternal antibodies would minimize symptoms but allow natural antibodies to develop. The concept of immunity arising from early exposure to the polio virus in crowded, unsanitary conditions, and with increased vulnerability associated with limited early contact with the virus, became the explanation for the increasing frequency of polio outbreaks beginning in the early 1900s. And then in August of 1921, Franklin D. Roosevelt, the former Secretary of the Navy and a recent candidate for Vice President, came down with polio and was left paralyzed below the upper thigh in both legs. FDR symbolized many of the characteristics of an individual at high risk of this infection. He had been tutored as a child and had none of the childhood diseases because of lack of exposure until he started boarding school as a teenager, so his general immunity to viral infections was likely low. The week before he fell ill, he visited a Boy Scout gathering, allowing exposure to a large number of individuals in the age group known to harbor the virus. He then engaged in a series of physically demanding activities which included running and swimming in ice-cold water. A history of both high activity and, quote, chilling, end quote, were reported in many cases of polio. His case embodied all of the factors thought to predispose an individual to polio. Although his age was not entirely typical, the age at polio diagnosis had been increasing, and in 1921, when he fell ill, 30% of cases were over 10 years of age, and this increasing age with infection is shown on the next slide. FDR's diagnosis made polio front-page news all over the country. He never walked again without assistance. He tried every available therapy, most notably swimming and exercising in natural hot springs in Warm Springs, Georgia, which became a destination for many polio survivors. Despite his disability, Roosevelt campaigned for governor of New York State in 1928 and won. With the help of his staff and the support of the press, he hid his inability to walk very skillfully. The picture above shows him using handrails for support and swinging his legs down the steps. That's on this slide. In 1929, the stock market crashed and the Depression began. Many Americans blamed the Republican president, so the field was wide open for an effective Democratic campaigner like Roosevelt. Despite his very significant handicap, Roosevelt campaigned hard, and in 1932 he became president. This had very important ramifications for polio and for medical research. FDR's involvement began with a fundraising plan to keep Warm Springs, Georgia going in the depths of the Depression, using a national advertising campaign based on the link between the president and polio. Local birthday balls were planned across the country to celebrate the president's birthday, with $1 from each ticket going to the Warm Springs Endowment Fund. A ticket for one of these events is shown below. The response was amazing, with more than 6,000 parties held on the night of January 19, 1934. In the depths of the Depression, Roosevelt received a check for over $1 million. In subsequent years, with Warm Springs well taken care of, the plan shifted so that 70% of the income from the birthday balls would stay in their local communities for care of polio victims. But with increasingly negative press arising from Republicans implying that the money raised was not being used appropriately, Roosevelt ended the birthday balls and announced the funding founding of a nonpartisan National Foundation for Infantile Paralysis in 1938. Until that time, medical research was funded largely by individual researchers using their own income or in rare research institutes established by wealthy philanthropists. One of the latter, the Rockefeller Institute, had been researching polio without success since 1902. The National Foundation for Infantile Paralysis recruited a new director from the Rockefeller to direct polio research, and he outlined key basic priorities for conquering the disease. The foundation established major virus laboratories at Yale, Johns Hopkins, and the University of Michigan, and the first coordinated research attack on polio began. Meanwhile, the National Foundation for Infantile Paralysis successfully broadened its fundraising to include movie collection boxes and celebrity endorsements, plus the collection of dimes mailed directly to the White House. Ultimately, this, quote, March of Dimes, end quote, became the name for the entire organization. As the United States entered World War II, after Pearl Harbor, the organization geared up to maintain its revenue stream to support the care of polio victims and to sustain ongoing research. Beginning in 1942, there was a steady increase in the number of polio cases in the United States, with a series of localized epidemics from 1944. The number of cases annually continued to increase, peaking at 57,000 in 1952. As shown in the graph above on this slide, the average age at diagnosis, as shown in the previous slide, the average age at diagnosis increased each decade, with 60% of cases over 10 years of age by 1952. It also became clear that the risk of paralysis and death increased significantly with increasing age of the victim. There was a rising tide of panic in the country, with Americans naming polio as their greatest fear after nuclear attack. Against this backdrop, the March of Dimes sustained its successful fundraising, adding poster children, healthy polio survivors, as models for what continued funding for care and research could achieve. And one of these posters is shown on the next slide. What were the results of decades of polio research funded by the National Foundation? After many years of confusion, the virus had been clearly shown to enter the body through the mouth, multiply in the throat and the GI tract, and then enter the bloodstream. As soon as the virus entered the body, research showed that in the vast majority of cases, antibodies were produced that neutralized the virus, limiting the spread of viremia and preventing access to the central nervous system. It was now known that there were 3 specific types of poliovirus, and a method for growing the virus in test tube had been developed. However, progress in treating polio was non-existent. The focus of research turned to development of a vaccine. There were major early contributions for development of both a killed virus vaccine and a live virus oral vaccine, but the rivalry between Jonas Salk and Albert Sabin, both funded by the National Foundation for Infantile Paralysis, is legendary. Salk's lab at the University of Pittsburgh developed a technique for isolating pure polio virus. He selected 3 strains, 1 of each type, and then inactivated them with formaldehyde and tested the most virulent type 1 strain safely in monkeys. He then tested the vaccine in institutionalized children at 2 facilities, the Watson Home, a rehab facility for polio survivors, and at the Polk School for the Retarded and Feeble-Minded, a public institution for children with IQ scores below 50. At that time, believe it or not, experiments on institutionalized children were considered acceptable if they could theoretically benefit from the intervention. In both settings, the vaccine proved safe, with no illnesses reported and high antibody titers. In January of 1953, Salk reported his results to the National Foundation's Committee on Immunization, which was composed primarily of virology researchers, which were also funded by the National Foundation. The report was greeted primarily with skepticism and jealousy. There was discussion about a large field trial, but no definitive plan. Then, before Salk could publish his work, news of the vaccine leaked into the lay press, with an article in Time magazine reporting, quote, "solid good news on the polio front," end quote. Public demands for an effective vaccine increased exponentially in response to this preliminary report in the context of the ongoing epidemic. Salk and the National Foundation were thrust into the potentially awkward position of essentially denying desperate Americans access to a vaccine that had been developed by their own donations. Salk's results were reported in the Journal of the American Medical Association, and subsequently he and the National Foundation began planning for a major polio vaccine trial. There was a major struggle over the design of the trial, but ultimately there were two limbs, with injection of second graders with real vaccine and observed controls in the first and third grades in 127 counties, and inoculation of all first, second, and third graders, half with vaccine and half with placebo, in 84 counties. Combined, the trial included almost 1.5 million school children, the largest public health experiment in American history. Public attention was riveted on the vaccine trial, which was extensively covered in the press. 2/3 of Americans were reported to have donated to the March of Dimes in 1954. The entire cost of the trial was supported by the National Foundation, which also undertook the training of all of the trial personnel. Using National Foundation dollars, a vaccine evaluation center was opened at the University of Michigan under the direction of Thomas Francis. Despite negative commentaries from live virus vaccine advocates, the world's largest field trial began on April 26, 1954. The field trials ended in late spring, just before the beginning of the polio season. The results were announced at a press conference at the University of Michigan on April 12, 1955. Although the full report was very detailed, the bottom line was clear. The vaccine was up to 80% effective in preventing paralytic polio. Edward R. Murrow, the father of broadcast news, attended the presentation and announced the results from his show on location in the Vaccine Evaluation Center in Michigan that night, with Drs. Salk and Francis as his guests. When asked who owned the patent on the vaccine, Salk replied, "Well, the people, I would say. There is no patent. Could you patent a son?" Salk was a hero. As David Oshinsky wrote in Polio, An American Story, "Here truly was the people's vaccine, spearheaded by a charitable foundation, driven by the spirit of voluntarism, subsidized by millions of small contributions, aided by numerous scientists, tested by enthusiastic volunteers, birthday balls, marching mothers, poster children, all had played a role. Developed in the public interest, this particular vaccine belonged to everybody." And one of the newspapers with the huge banner headline, "Salk's Vaccine Works," is shown on this slide. The response to the Salk vaccine program was dramatic, and that is shown on the next slide. In 1954, there were 30,000 cases of polio in the United States, compared with 1,000 cases in 1960. The vaccine program was not without problems, but the dramatic success was obvious. Nonetheless, research on a live virus vaccine continued, led by the laboratory of Albert Sabin at the Children's Hospital of Cincinnati. There were sound immunologic reasons to theoretically prefer a live virus vaccine, principally the fact that the antibody response was much more pronounced and long-lasting. While the Salk vaccine required 3 injections and subsequent boosters, a single oral dose of an attenuated live virus was projected to produce lifelong immunity. In addition, since those who ingested the oral vaccine would excrete the weakened virus in their stools, essentially immunizing others in the population with the oral vaccine had the potential to wipe out polio completely. While the Salk vaccine was being developed and tested, Sabin's lab continued to work on a live virus vaccine, work which he began in 1951. Sabin weakened the polio virus strains by passing them through monkey tissue in rapid succession until a sufficiently weakened virus was produced. By 1954, he had developed a vaccine that did not produce paralysis when injected directly into the spinal column of monkeys, and in the winter of 1955, he tested it in 30 adult prisoners who had no poliovirus antibodies. All 30 developed antibodies and none became ill. However, proceeding with further live virus testing, especially in children, was blocked over concerns about reversion of the attenuated virus back to a more virulent state, coupled with loss of public interest in light of the successful Salk vaccine campaign. In 1956, Sabin took advantage of a visit from Russian scientists to establish a relationship with the University of Leningrad. Ultimately, with the approval of the U.S. State Department, a mass immunization program using the oral attenuated virus vaccine began, with a plan to immunize every Russian under the age of 20, 77 million individuals. The first results were available within a year, with a dramatic decline in paralytic polio cases verified by the World Health Organization. In 1960, the Soviets presented the results of their national vaccination campaign, reporting very significant progress towards the eradication of polio. Back in the United States, the steep decline in polio cases in response to the Salk vaccine led to a major decline in public interest. The National Foundation, now known as the March of Dimes, was in danger of becoming a platform without a cause. Reluctantly, the organization moved on to support research in birth defects and prematurity. With the success of the live virus vaccine in Russia, Sabin conducted a new trial in the U.S. in which the vaccine was given orally as a single dose in 200,000 individuals, primarily young children, and the results led to trial development of the Sabin vaccine in the U.S. in 1960. Then the AMA voted that the Salk vaccine be replaced by the Sabin oral vaccine when it became available. Despite Salk's efforts to defend it, 1961 was the last year in which his vaccine was exclusively used to prevent polio. Over the next 3 decades, the live virus vaccine was the vaccine of choice, despite clear demonstration that the majority of remaining polio cases in the United States were directly related to the live virus vaccine. That is where the matter stood until 1996, when the CDC made a major new recommendation. Wild polio virus had been eliminated in the Western Hemisphere, but there were a small number of polio cases every year, and all were attributed to the live virus vaccine. The only way to eradicate polio completely was to eliminate live virus immunizations, returning to the Salk-killed virus vaccine, which became the CDC's formal recommendation in 2000. The polio experience is unique among epidemics and within known medical history. The pace and direction of scientific progress was dictated by the public, fueled by media reports of dying and paralyzed children, with the work of scientists funded almost entirely by public donations. There is no doubt that short-term development of the inactivated virus vaccine over long-term development of the live virus vaccine was driven by public opinion, exacerbated by publicity produced by what constituted mass media at the time. The polio endgame is a worldwide public health effort to eliminate all cases of poliomyelitis infection. This began in 1988, led by the World Health Organization, UNICEF, and the Rotary Foundation, and funded to a great extent by the Gates Foundation. The Global Polio Eradication Initiative, GPEI, was inspired by Rotary International's 1985 pledge to raise $120 million with the goal of eradicating polio in the world by the year 2000. The fight to eradicate polio has reactivated the original battle between the injected killed virus vaccine developed by Salk and the oral attenuated live virus vaccine developed by Sabin. The killed virus vaccine cannot replicate and cannot cause disease. However, a series of shots are required to produce long-standing immunity, making it more difficult to administer and more expensive. By contrast, the oral polio vaccine confers lifelong immunity, is easy to deliver by mouth, and is inexpensive. However, the attenuated virus can mutate and can rarely cause polio. When this occurs in a largely unvaccinated population, the vaccine-derived polio virus can cause polio outbreaks. A recent study estimated that vaccine-derived virus infected 700,000 people between 2005 and 2011, although only a small number developed paralysis. It is clear that complete elimination of polio will require elimination of It became clear that complete elimination of polio would require elimination of the oral polio vaccine. Polio vaccination is also important in the development of herd immunity. For polio to occur in a population, the virus needs a susceptible human population and a cycle of transmission. Poliovirus is transmitted only through person-to-person contact from one infected person to another person susceptible to the disease, and so on. If the vast majority of the population is immune, the ability of the poliovirus to infect another host is reduced. The cycle of transmission is interrupted. The virus can only survive for a short time in the environment, so without a human host, the virus dies out. This concept, called community immunity or herd immunity, is important to disease eradication because it means that it is not necessary to inoculate 100% of a population, a goal that is often logistically very difficult, to achieve the desired result. If the number of susceptible individuals can be reduced to a sufficiently small number through vaccination, then the pathogen will eventually die off. Herd immunity can only be achieved when vaccination levels are high, estimated at 80 to 86%. If routine immunization were stopped, the number of unvaccinated susceptible individuals would soon exceed the capability of herd immunity to protect them. In addition to issues related to vaccination, there are other major problems that have delayed eradication of polio. These include the lack of basic health infrastructure limiting vaccine distribution and delivery, the crippling effects of civil war and internal strife, and the sometimes oppositional stance that marginalized communities have taken against what is perceived as a dangerous external intervention. Another challenge has been maintaining the potency of the live vaccines in extremely hot or remote areas because the oral vaccine must be kept at 36 to 46 degrees Fahrenheit for vaccination to be successful. Nonetheless, by 2001, 575 million children, almost 1/10 the world's population, had received some 2 billion doses of oral polio vaccine. The WHO announced that the Americas were polio-free on August 20th, 1994, and that Europe was polio-free on June 21st, 2002. Over the last 25 years, the Global Polio Eradication Initiative has reduced the number of annual diagnosed polio cases from the hundreds of thousands to only 291 in 2012, a dramatic 99.9% reduction. This has required major public health education and immunization campaigns in countries all over the world and has not been without adversity. Even with the express support of political leaders, polio workers have been kidnapped, beaten, and assassinated, and pockets of disease persist. Over the 27 years since the GPEI began, important milestones have been achieved with elimination of polio in North and South America in 2000 and Europe in 2002. By 2006, only 4 countries in the world, Nigeria, India, Pakistan, and Afghanistan, were reported to have endemic polio. Cases continued to occur in other countries, but these were attributed to importation. Each year until 2010, approximately 1,500 to 2,000 cases of polio were reported, with 80% occurring in the 4 endemic countries. There was a further decrease in the last 5 years. By 2012, several countries reported that more than a year had passed since their most recent reported case of polio. Most notably, the WHO reported that India completed its first polio-free year and was declared polio-free, leaving only Nigeria, Pakistan, and Afghanistan afflicted by endemic polio. In late April of 2013, the World Health Organization announced a new $5.5 billion 6-year cooperative plan to eradicate polio from its last reservoirs. The plan calls for mass immunization campaigns in the 3 remaining endemic countries. It also dictates a switch to inactivated virus injections to avoid the risk of the vaccine-derived outbreaks that still occur from use of the live virus vaccine. In May, Bill Gates announced at the Global Vaccine Summit that total commitments to the program stood at 73% of what is needed, with pledges from many first world countries, the Islamic Development Bank, as well as the Gates Foundation. On March 27, 2014, the World Health Organization announced the eradication of polio in the Southeast Asia region, in which are included 11 countries. With the addition of this region, the proportion of world population living in polio-free regions has reached 80%. By the end of 2014, only 359 cases of polio due to wild virus and 54 cases due to vaccine-derived disease had been reported. The WHO decision in 2013 to switch to inactivated virus injections to avoid the risk of the vaccine-derived outbreaks is taking effect, with the last reported case of vaccine-derived poliovirus in December 2014. The Polio Eradication and Endgame Strategic Plan projects the world will be polio-free by the end of 2018.